hypotenuse. Well, the square on the hypotenuse is the sum of the squares of the other two sides. Or the politically incorrect way of saying that is, the square on the hippopotamus is the sums of the squares on the other two hides. That's the punchline of a joke, which I'm not going to tell the joke because it's not worth it. Yeah, it's going to be the positive square root because it's a length, right, of the sum of these squares. And so you can either write 1 plus y squared or y squared plus 1. What's your pleasure about y squared plus 1? Right, so now what is the cosine of that angle? Yeah, y over, there you go, right. So this is going to be opposite over hypotenuse. Yeah, I reversed the squares, but same thing, right? Okay, well that's not great, but you know, it's something. How about the sine of the angle whose sine is x? Who's buried in X's tomb? X. If you take the sine of the angle whose sine is x, it's going to be x. How about the cosine of the angle whose tangent is y? Well, then you look at this picture again, right? Just remember your, do people say SOHCAHTOA? Yeah.
Wait, so what? Oh, look at the cosine.
Cosine of the angle whose tangent
So it's
is y.
one-
So
it's one
that's
over-
why we drew this picture, so we can compute that easily, right?
It's 1 over square root of y squared plus 1.
Yeah.
Why isn't it the same? Why isn't it the same?
Okay, so now, can we simplify the rest of this? I don't know, maybe.
Wait.
Wait. Yeah, because
We got a common denominator, so we can write this as y. I'm going to write the y factor first, so it's obvious it's not under the radical. Okay, so this is product
X
plus x all over
sine is
square
x
root
over
of
1.
1 plus y squared. Does that simplify? Not really. That's kind of it. Yeah. All right. That's what they want us to do in number 47. Oh, yeah, right. Yeah.
Do you want to get the square root out from the bottom there?
Do you? Okay.
Why do you?
I no. I mean, sometimes it makes sense to. That would be rationalizing the denominator, right? Or getting the radical out of the denominator, to be sure. That would do that, right?
You would just multiply top and bottom by the same value, wouldn't you?
Right, and so that would be radical 1 plus y squared. The thing is, y squared could be irrational, in which case you haven't really rationalized the denominator, right? Plus, you're going to make the numerator a lot worse looking. So maybe just leave it like that. Yeah. All right, well, there's 3 more like that, okay? And how are we doing now? Identities involving, so there's more exercises. Expressions involving inverse trigonometric functions, okay, so how about, yeah, well, number 54, just as a...
We're going to take a quick picture of that real quick.
Okay. So...
Okay, you're good. Thanks.
So 54 is the sign of the difference where you got 2 angles. One is the angle whose cosine is 2/3. Is that what it is? Yeah. And the second one is the angle whose tangent is 1/2. Are these well-known angles? No. Right, these aren't well-known. Otherwise, we could substitute, what we know they are. So, but we can draw pictures, right? So if this is a right triangle, and this is the angle whose cosine is 2/3, how would you label the sides? Well, you want adjacent over hypotenuse to be in the ratio of 2 to 3. What's convenient labeling then? It could be 4 and 6, right, or 8 and 12. But you want to put 8 and 12 here? That would work. But that would be kind of absurd, right? Much simpler just to write adjacent is 2 and hypotenuse is 3. It's the same ratio, right? So it'd work in either case, but you would particularly pick the simplest one, right? So if that's the angle whose cosine is 2/3 in a triangle, right triangle, then the ratio of those sides should be in the ratio of 2 to 3, so why not make them 2 and 3? What does that make the opposite side?
2, 3. 2, 3.
Square root of, nope.
Square root of,
we can get it.
5.
5.
right?
Yep.
9 minus 4 is 5.
4, 5.
Okay. What about the other one? I'm not making these in proportion, right? I'm just drawing a figurative triangle for the purposes of computation, right? So if this is the angle whose tangent is 1/2, then this would be in the ratio of 1 to 2, right? Oh, and this would be square root of 5 again, right? Since 1 squared plus 2 squared is 5. Okay, so that's handy. So now, the first thing I would use is the addition identity or the subtraction identity, whatever you want to call that. So it's going to be sine of the angle whose cosine is 2/3 times the cosine of the angle whose cosine is 2/3. I wonder what that could be. Minus the cosine of the angle whose cosine is 2/3. Again, a big mystery here. And then the sine of the angle whose cosine, whose tangent is 1/2. Did I get that right? Too close to it to see. Oh, yeah, that looks wrong. Yeah. So sine of alpha minus beta is sine alpha cosine beta. So I put the wrong thing here.
It's tangent.
It should be tangent. The angle whose tangent is 1/2. Sine of alpha cosine beta minus cosine alpha sine beta. That's right. Okay, so now I can use these diagrams to figure out what I want, right? So the sine of this angle is opposite over hypotenuse. I'm just going to write that. The cosine of this angle is adjacent over hypotenuse. I'm going to write that. All right, and then I'm going to subtract from that 2/3, right? And the sine of this angle is 1 over root 5. So here the root 5's cancel out, so I get 2/3 minus 2 root 5 over 15, huh? Here we should rationalize the denominator, because 15 is much simpler to divide by than 3 root 5. Yeah, so that's a number. Is it a number between -1 and 1? It better be, right? Should we approximate it? This is 0.6 repeating. This is 2.24, 4.47 over 15. I'm guessing here that I got that to the nearest hundredth. So that's approximately 0.6 repeating minus 15 is going to go into that almost 5, right? But 4, so that leaves, oh, what? So almost 3, so 2. 147, 9, I guess, right? And so, yeah, that's a number between, so this is gonna be approximately 0.37, something like that. In that ballpark, right? So it's a positive number, and I suppose we could dial up things, but let's say we're done and move on. Okay, so
Right there.
evaluating expressions involve trigonometric functions. So quadrant 4, quadrant 2, how about tan of a sum in 58? We know the cosine of theta is -1/3. Theta is in quadrant 3. So what does that mean? So this is number 58 now.